Hi, in this question, we are going to solve this linear programming problem together. Here's the question. Maximize z equals 3030x1 plus 1010x2. Maximize this function given the constraints 1, 2, 3, 4, 5, and 6. And these constraints are given in the question. So how should we solve this question? The method that I recommend you to do is first you want to draw the constraints on the graph and find out the feasible points or feasible areas, and then you want to find the corner points and afterward identify which point will maximize or minimize the objective function. So that's the way to go. So if you simplify the constraints, you will have this. So constraint number 1 was reduced to 33x1 plus 11x2 is less than equal to 270,270. And a second constraint was 11x1 plus 11x2 less than equal to 160,160. And third constraint, 11x1 is less than equal to 9090, and 11x2 is greater than 40, and x1 minus x2 is less than 0, and x1 and x2 are greater than 0, where we can try to draw these constraints over here. So here is the first constraint. 240,470 is the intercept for x2, and then 80,190 is intercept for x1. And for the second constraint is right here, 140,560 is the intercept for x2. 140,560 is another intercept for x1, and so forth. You can draw the constraints. And another thing that you want to take a look at is the symbol greater than equal to or less than equal to or equal to. That's a very important symbol. And depending on the symbol, for example, here x2 is greater than equal to 11x2, meaning that x2 has to be greater than x1. Therefore, it is above area, not less than or below area. And most of the constraint says less than equal to, so the arrow that I indicated here says below. And if you look at this one, x2 is greater than 36.73, and that has to be drawn, and then it's greater, so the arrow is upward. And lastly, you get here x1 is less than equal to 826, so the arrow is to the left. It's that's the direction. And after looking this one, you want to find the feasible area. So shade those areas all together and find the common area. And this is the graph. So if you find the feasible area, this shaded area is the only area that where we can consider the solutions. And here we find that there are 5 corner points, A, B, C, D, E. We have 5 corner points, and you can calculate what these corner points are, x1, x2 coordinates yourself. However, one faster way of finding is looking at the objective function. So I went back to objective function here. Z equals 3030x1 plus 1010x2. And if you solve for x2, let's just say set this equation as k, and then solve for x2, then you get x2 equals negative 1 over 3x1 plus k over 3030. And what you get here is that the slope of this equation is negative, and therefore, if you go back to the previous graph, here the slope is negative, and when the ratio between x2 and x1 is 1 to 3, and therefore I find that the more x1 you may have, the better or the higher z-score or objective function you will have. So or let's go back to the objective function again, and it shows that 3030 x1 plus 1010 x2, and obviously you can see that the more x1 you have, the bigger z will be, right? So say x1 is 1 and x2 is 1, then you will have 33 plus and 1010, and that's going to be 4040. Say x1 is iPhone, x2 is say iPod. iPhone is more expensive than iPod. As a result, say you are making $3,030 for x1 or iPhone, and obviously you want to produce more x1, given that x1 is going to be producing more profitability for your business. Given that, we go back to the graph, and among A, B, C, D, E, we see that we want to choose the highest x1 value, which is here 826, and also the highest x2 value, that's 14,560, but at that point coordinate A, x1 is 0, so that's not a good solution, but B will be a better solution. So we find that B should be the optimal point where you want to choose as the solution. If you've identified this solution, now you want to go back to the objective function, and we find that the bigger x1 is, the bigger z is. So therefore B is the solution. And therefore now we need to calculate for coordinate B. And how do we do that? If you look at this point, we find that this equation 11x1 plus 11x2 is less than equal to 160,160, and this graph vertical line, which is x1 is less than equal to 826.36, and these points are intersecting together, so we have to calculate, set them equal, and calculate for the solution. So here's the solution. So constraint 2, x1 plus x2 is 14,560, and constraint 3, x1 is 826.36. So you calculate that. I'm using subtraction method here. I just subtract the second equation from the second one, from first equation. Then x2 equals 140. Actually 137. I think I gave you a wrong answer here. 137. 13,733.64 is the solution for x2, and x1 is given here. x1 equals 826.36. So you plug that into this z function as shown. I made the mistake here. x2 should be 13,736.64. So you put that in here and find the z value. Then it's going to be your profit in this case. So again, when you are solving linear programming methods, first draw all these constraints on the graph and find the corner solution and feasible area, and identify which one will serve as the maximum or minimum. And that's the way to go when you are solving linear programming. Thank you.